Okay, good morning everyone. Today we will discuss about the signal flow graph and how to solve the problem for finding the transfer function for the given signal flow graph. So this is the example. This example we will cover now. So the given question is find the overall gain C of S by R of S for the signal flow graph shown in figure below. So this is the signal flow graph given. So for this, now we have to find out the transfer function. The transfer function for the signal flow graph can be found from the Mason's gain formula, and the Mason's gain formula is given by transfer function TF equal to C of S by R of S, so which is equal to 1 by delta summation K Pk delta K. So this is the Mason's gain formula. So generally it is given by T equal to 1 by delta P equal to 1 by delta summation K Pk delta K. So here I have taken C of S by R of S. So generally the transfer function is defined as ratio of Laplace transform of output to Laplace transform of input, considering neglecting that initial condition. So here R of S is the input and C of S is the output. So generally here see delta 1 by delta 3 parameters we have delta K, P, K and delta K here. So K represents the number of forward paths. So how many forward paths are there? So that indicates the K. So forward path from R of S to C of S, the direction in the forward direction only. So that type of how many paths are there, so that gives K value. After finding the K value, then we can find Pk. So for example K equal to 2, so we have to find out P1, P2. Similarly delta 1 and delta 2. So what is P? P is nothing but forward path gain of the kth forward path. For example P1 indicates forward path gain of first forward path. P2, let P2 indicates forward path gain of the second forward path. So similarly here delta. So delta is given by 1 minus sum of individual loop gains plus sum of gain product of two non-touching loops and so on. And similarly delta K equal to delta for the portion of the graph which is not touching the kth forward path. For example delta 1 equal to delta for the portion or part of the graph which is not touching the first forward path. So these are the parameters. So individually we find what is delta and what is K, what is Pk and what is delta K, then we substitute, then we will get the overall transfer function for the given signal flow graph. So first we find out how many forward paths are there. See, these are, see this in this graph, this circle, small circles indicates that node. So node is nothing but a meeting point like a junction, and this arrow indicates a forward direction. This arrow head, it is showing in that direction, means it is moving in this direction, that is forward direction. So R of S is the input, it has to reach the output to C of S. So I have used different colors. So node, this black color is used and this violet color, arrowhead indicating in the forward direction here. And again we have the loops. So what is loop we will see. So for example here see the nodes, node 1, node 2, node 3, node 4, node 5, node 6, node 7. Total 7 nodes are there. So from node 1 to node 2 here indicated with 1, and this arrow is indicating the forward direction. 1 indicates the transmittance from 1 to 2. And similarly 2 to 3 it is G1, and 3 to 4 G2, 4 to 5 G3, and 5 to 6 G4, and 6 to 7 it is 1. And again here we have some feedback paths are there. So for example here observe from 5 to 3 there is a feedback path, means the arrow direction is showing in the reverse direction, opposite direction. This is the forward direction and is showing in the opposite direction. So here gain is given as minus h2, and here from 6 to 4 the gain is given as minus h1, and from 6 to 2 it is given as a minus 1. Okay, that is unity gain, that is with a negative sign. Now observe how many forward paths are there. So first you take from the initial node 1 and it has to reach output node 7 in the forward direction. So from 1 to 2 there is a forward direction, and 2 to 3 forward direction, 3 to 4 forward direction, 4 to 5, 5 to 6, 6 to 7. One forward path is from node 1 to node 7. It is covering all nodes. Actually in every problem, if you consider input node to output node, so generally we will choose all the nodes. So first forward path, generally it will cover all the nodes. So first we have to go for finding the forward path gain. Forward path gain. So forward path gain calculation first. So first draw the forward path. So node 1, node 1, node 2, node 3, 4, 5, 6 and 7. So give the names, one numbering 1, 2, 3, 4, 5, 6 and 7. So initial node we apply the input, and at output we collect the output node 7, we collect the output, and here arrow direction you have to show, it is very important. So means it is indicating that the signal is flowing in forward direction. So what is the gain from 1 to 2? 1 to 2 gain is 1. You observe the given problem and note down the transmittance. From 2 to 3 it is G1, and 3 to 4 G2, and 4 to 5 it is G3, and 5 to 6 G4, and 6 to 7 it is 1. So now find the forward path gain. This is one forward path. Let it be the first forward path P1. So P1 equal to, now so multiply all the transmittance from node 1 to node 7, that is 1 into G1, G2, G3, G4 into 1. So it will be G1, G2, G3 and G4. So this is the forward path gain. First forward path P1 indicates, see, Pk, that is k equal to 1, first forward path gain. Now you see if another forward path is existing or not first. So 1 to 2, so already we have checked from 2 to 3 we have the forward path. Now you can observe from 2, again one possibility is there or not, you check. See, from 2 it is flowing in this direction. So here if you observe there is opposite direction, means it is not a forward path. From 2 in this direction, 2 to 6 there is no forward path. So next you move to the next node, here 3, another possibility you check here. 3 to 4 already we have checked. Now 3 another direction, you observe. So here signal is flowing in the opposite direction, means it is not a forward path. Next move to 4, node 4. From node 4 to 5 already we have observed 4 to 5. Now you check any other possibility is there or not in this direction, 4. So here the signal is moving in the opposite direction, means there is no forward path. So here we have only one forward path. So number of forward paths, see, number of forward paths, number of forward paths. So there is only one forward path. So k equal to 1. Okay, equal to 1. So next we find out what is delta. Okay, what is delta? So what is delta? See, calculation of now delta, or find delta. Calculation of calculation of delta. So what is delta? See, delta equal to 1 minus sum of individual loop gains. See, 1 minus sum of individual loop gains plus sum of gain product of two non-touching loops. So here we require See, 1 minus sum of individual loop gains. So first find out what are the individual loops and calculate its gain. So we will get one part, that is 1 minus sum of individual loop gains. So next we have to find out the sum of gain product of two non-touching loops. So first we will see, afterwards we will calculate delta. So first we will see the individual loop gain. So individual loop gain calculation. Okay, na loop gain we have to find out. So first find out what are the individual loops. See, the first node will not get any loop here, any other channel is not there here. See, from 2 to 3 forward path, and 3 to 4 one forward path, and 4 to 5 and 5 to 6. If you observe, there is a feedback path is there here. So from 6 to 2 there is a feedback path which is going to form a loop, means it is going to start at the same node and it is going to end at the same node. See, from 2 it has started and it is had ended at the same node, that is 2. So 2, 3, 4, 5, 6 forms one loop. So 2, 3, 4, 5 and 6 forms one loop. So let it be some 2, 3, 4, 5, 6. So this is forward direction, forward direction, forward direction. Now you can observe from 6 to 2 it is going to flow in the same direction. So branch has started at 2 and it has passed to other nodes and finally it has ended at the same node. So 2 to 3, what is the gain here? G1. So this is G1, G2, G3 and 5 to 6, G4 and 6 to 7. 6 to 7 the gain is minus 1. So minus 1. So this is the one individual loop gain. So P11. See, what is P11 we will discuss. So G1. So you multiply all the transmittance, it is a loop, that is G1, G2, G3, G4 into minus 1. So which will be equal to minus G1, G2, G3 and G4. See, we have given one indication here, P11. See, P suffix 11. So this first 11 indicates that this one indicates individual loop gain. So this one indicates first individual loop gain. Okay, na first individual loop gain. So we will see, we have any other individual loop is there, we will check it first. So this is P11. So any other loop from 2 only one loop is possible, and go to the next node 3. See, 3 to 4 forward direction and 4 to 5 forward direction, and 5 we have a feedback, that is another branch is there, it is going to go and reach node 3 and it is going to end at node 3. So 3, 4, 5 forms one loop, individual loop. 3, 4 and 5. 3, 4 and 5. So 3 to 4, 4 to 5 and 5 to 3. So 3 to 4 the gain is G2, and 4 to 5 the gain is G3, and 5 to 3 actually we have to draw in top, so no problem in this way also. See, 3 to 4 and 4 to 5 in this direction. So 3 to, this is minus H2. So you can represent in this way, or you can show in this direction also. So anyone is same. So which is P21. This is P21. That is second individual loop gain. See, one indicates individual. Now you can observe the difference. P11 and P21. This one indicates individual loop, and the prefix, that is 2, indicates the second individual loop gain. Multiply all the transmittance, that is G2, G3 minus H2, that is minus G2, G3 and H2. So that is the second individual loop. And now if there is a possibility another loop is there. So 3 it is completed. Now go for checking another one, 4 to 5 and 5 to 6, and from 6 to 4 another loop is there. So 4, 5, 6, 4, 4, 5, 6, 4, 5, 6, another loop. So 4 to 5, the gain is G3, and 5 to 6, G4, and 6 to 4, that is minus H1, minus H1. So P31 equal to P31. So multiply the each transmittance, that is minus G3 G4 minus G3 G4 H1. So these are the individual loops. Is there any other loop is there? Now just we will check it. So we have find 2 to 3, 3 to 4, 4 to 5 and 5 to 2. One node is completed, and next 3, 4, 5 and 4, 5, 6 completed. Only 3 individual loops are there. So next we have to find out what are the non-touching loops, 2 non-touching loops. The possibility is, so here as we have 3 individual loops, so we have to search for whether 3 non-touching loops are there, next 2 non-touching loops are there. You have to check. So here we will see. So just I will rub this. So we remember only one forward path is there, and whose gain is G1, G2, G3, G4. So now gain product of finding gain product of 2 non-touching loops. See, sum of gain product of gain product of 2 non-touching loops, 2 non-touching loops. So observe what are the non-touching loops. See, here we have 3 individual loops are there. You check one by one. Let it be first individual loop, second individual loop and the third individual loop. So first you compare first loop with the second one. So non-touching means, see, touching loop means if the common node, even one common node is present in the 2 nodes, you can say they are touching loops. So here we require the non-touching loops, means the common nodes should not present in the 2 loops, even one node also. So 2, 3, 4, 5, 6. So here we have 3, 4 and 5. So 3, 4, 5 nodes are present here. So these 2 are touching loops. So here we require non-touching loops. Now you observe here, you compare one with the third one. Again here we have 4, 5, 6. So first one is touching with the remaining loops. And now compare second one and here also touching, means common node is present here 4, 5 is present. So here there are no 2 non-touching loops. So here in this problem there are no 2 non-touching loops. 2 are 3 non-touching loops. Non-touching loops. See, no need of calculating that remaining part because there are no non-touching loops. See, everywhere, example you observe 3, 4, 4. In all 3 loops, common node is 4. So there is a one touching loop is there minimum. So delta, now see calculation of delta. See, delta formula, delta equal to 1 minus sum of individual loop gains. See, individual loop gains plus sum of gain product of two non-touching loops, loops minus so on, means so the sum of gain product of 3 non-touching loops plus sum of gain product of 4 non-touching loops. So first we will calculate what is delta. See, delta equal to 1 minus sum, means add all the individual loop gains. Already you have calculated the individual loop gains, that is 1 minus of what are the individual loops? P11, sum means you have to add. So P21 plus P31. So remaining portion is not there. See, 1 minus sum of individual loop gains plus sum of gain product of 2 non-touching loops. Here we have written already. There are no 2 or 3 non-touching loops, means that portion is 0. See, delta equal to 1 minus of what is P11, that is G1, G2, G3, G4 minus G1, G2, G3 and G4. Next P21, that is minus G2, G3, H2 minus G3, G4, H1. So delta equal to 1 plus G1, G2, G3, G4 plus G2, G3, H2 plus G3, G4, H1. This is delta. So now next we have to find out what is delta K. So delta K equal to the last parameter here, delta K we have to find out. So delta K, here K value equal to 2. The K value equal to 1, not 2, because we have only one forward path is there. So K equal to 1. So delta 1 we have to find out. So what is delta K? Delta K equal to delta for the portion of the graph which is not touching that particular part of the first forward path. So here, so delta already you know, this is the formula for delta. So for delta 1 equal to delta, same formula, this formula will be same, but the graph is different. See, this delta you have find for this problem, given a problem, this is entire graph. For this graph we have find what is delta. Now delta 1 means delta only, the graph is going to be changed. So what is that graph means? The portion of the graph which is not touching that kth forward path. So you know what is the first forward path. Already I have erased. See, first forward path, what is the first forward path? All nodes are present. 1, 2, 3, 4, 5, 6, 7. So all nodes are covered. So there is no portion of the graph which is not touching these nodes. See, without touching these nodes, no graph is there. Means delta K equal to delta, see, delta 1 equal to 1 minus, see, 1 minus sum of individual loop gain. There is no graph, means this entire portion is 0. So 1 minus 0 plus 0. So it is 1 only. So this is 1. Delta 1 equal to 1, because there is no graph which is not touching that first forward path. So generally first forward path for any problem, if you consider straight away from 1 to last node, so it will be 1 only. It will be 1. Now transfer function equal to, say, TF equal to TF, the TF indicates T transfer F function, which is equal to the formula 1 by delta summation K Pk delta K. we know what is k. Now k equal to 1. So transfer function is equal to 1 by delta summation. Here k is 1. So k equal to 1 pk delta k. So if we substitute k, so transfer function equal to, see, p1 delta 1 by delta. So we have already derived what is p1 delta 1 and delta. So transfer function is equal to C of s by R of s equal to, what is p1? Have you noted p1? So p1 from R of s to C of s. What is that p1? g1, g2, g3, g4. So p1 equal to g1, g2, g3 and g4. What is delta 1? Delta 1 equal to delta 1 equal to 1, that is p1 delta 1, p1 into 1, that is p1 only, you will get only p1 by delta. What is delta? This is the delta, 1 plus g1, g2, g3, g4 plus g2, g3, h2 plus g3, g4, h1. So 1 plus g1, g2, g3, g4 plus, next term is g2, g3, h2, g2, g3, h2 plus the last term g3, g4, h1. So g3, g4, h1. So this is the transfer function for the given signal flow graph. So we have find the transfer function using the Mason's gain formula. So this is the Mason's gain formula. Transfer function equal to 1 by delta summation k pk delta k, where k equal to number of forward paths and pk is corresponding forward path gain. Delta k is the corresponding delta for the part of the graph which is not touching that kth forward path. So delta is 1 minus sum of individual loop gains plus sum of gain product of two not touching loops minus so on. So one more problem we will discuss now. So